Okay, students, let us understand convolution of two given signals here. First, x of t is a pulse which exists from 0 to 3, and h of t is another pulse where it present from 0 to 0 to 2. We have to convolute these two signals. That means y of t, x of t convoluted with h of t. What is x of t? It's a pulse. What is h of t? It is also a pulse. Now, first point is to define these x of t and h of t in terms of unit, that means u of t. Now let me define. X of t is equal to u of t minus, it starts from 0, that means u of t, and ends at 3, hence minus u of t minus 3. Similarly, what about h of t? H of t on the same grounds with the definition of unit step, it starts from 0, ends at 2, hence u of t minus u of t minus 2. H of t also I have defined. Now I have to convolute these two. That is, y of t is equal to x of t convoluted with h of t. X of t I will replace in terms of unit step, u of t minus u of t minus 3. This is nothing but x of t convoluted with h of t, that is u of t minus u of t minus 2. U of t minus 2. Now I have to convolute this. See, let me take this inside. U of t convoluted with u of t minus u of t convoluted with u of t minus 3 minus u of t convoluted with u of t minus 2 plus last one minus and minus plus u of t minus 2 convoluted with u of t minus 3. U of t minus 3. Now at this point you have to see to that first whatever you are writing now, let it be, try to write it as u of t better, as well as the smaller one. I mean to say, see here, when you are multiplying u of t and u of t minus 2, I have written u of t in the first hand and then I have written u of t minus 2. Similarly, when I am multiplying u of t minus 2 with u of t minus 3, I mean to say when I am convoluting u of t minus 2 and u of t minus 3, how I have written is, first I wrote t minus 2 and then I wrote u of t minus 3. First, better you write a smaller one. Otherwise also you have to rearrange them in the later stage. Now u of t need to be convoluted with u of t. Let us define, you already know what is convolution. That means integration minus infinity to infinity. First signal you write it as u of tau dot, that means multiplication. Second signal u of t minus tau, u of t minus tau, minus integration minus infinity to infinity. First signal u of tau, that means instead of t you are writing tau, dot. Second signal u of t minus 3 minus tau, u of t minus 3 minus tau, minus integration minus infinity to infinity, again u of tau, dot u of t minus 2 minus tau, t minus 2 minus tau, plus integration minus infinity to infinity u of tau minus 2. You here you see t minus 2 is there, I am just making tau minus 2, dot u of tau minus 3 minus t minus tau minus 3, sorry, here it should be t minus 3 minus tau. This is how I have put the definition of convolution and I put it into integration like this. Now what you have to do is you have to write, because from where to where this exists. You know that u of tau starts from 0, hence my integration starts from 0, and where it ends at t here. You already know these concepts. And another important thing is, everywhere a d tau is missing. Okay, now it starts from 0 and ends at t, and this is also all our unit steps, hence 1 into d tau minus, see next, this starts from 0 and ends at t minus 3. See here, it ends at t minus 3. Again d tau minus, this integration starts from 0, u of tau is there, it starts from 0 and ends at t minus 2 d tau, plus the last integration whatever is there, it starts from tau minus 2 means it starts from 2, tau minus 2 means it starts from 2, ends at t minus 3, d tau. Okay, now you have written all this. I hope you understood these concepts I have explained you in class. It starts from 0 because u of tau is there, it starts from 0, and t minus tau is there, it ends at t. These all concepts I have explained clearly. If any doubts are there, you can reach me. Now at this stage you can rearrange the things. There are 4 integrations are present. Rearrange the things. For example, the first integral term whatever is there, no, it starts from 0 and ends at t. Okay, you should know where these 4 integrals starts and ends. This is very important. Anyway, this is very clear that it starts at 0 and ends at t. That means starting point is 0 itself. Hence this is first integration. Next, see this it starts, where exactly this starts? Not at 0 actually. It doesn't start at 0. It starts at t equal to 3. This starts at t equal to 3. Why it is? Because to have an integration, the lower integration and upper integration must exist there. Hence, it is only possible if t minus 3 equal to 0. That means this starts t minus 3 equal to 0. This starts at t equal to 3. This integration starts at t equal to 3. Similarly, what about the third integration, whatever exists here? It starts at t equal to 2. Okay, and this starts at, where this starts at, see how to calculate this. Last one I will show you how to calculate this. This starts at t minus 3 equal to 2. That means it starts at t equal to 5. This fourth integral term whatever is there, no, it starts itself at t equal to 5. Similarly, what about this t minus 2 equal to 0? It is very easy to find. Upper limit you equate it to lower limit. Upper limit you equate it to lower limit, you will get the point where your integration starts. Hence, if you analyze this, you can rearrange the terms here. You can rearrange the terms in the sense, see, this is first integration, this is second integration, hence I will write according to their numbers where they starts. You already know now, this starts at 3, this starts at 2, this starts at 5. Hence I will rearrange these things. 0 to t d tau minus, second I will write this 0 to t minus 2 d tau minus 0 to t minus 3 d tau plus 2 to t minus 3 d tau. Now these 4 terms serially I have written. I hope you understood. I have rearranged these terms. Why? Because their start is understood by you that this starts at 2, this starts at 3, this starts at 5. Hence, I wrote this starts at 0, starts at 2, starts at 3, starts at 5. Hence, in a ordered manner, I have written this. Now, I have to analyze and write this integration. Let me go ahead. Now, the first term I have written here first, second, third, and fourth. 4 integrations are there now. Where your first integration starts? First integration starts at t equal to 0 and ends at t. Okay, I will just wipe it out and let me do the rest part here on the other side of the board, so that all the things are there here and you will understand the things very clearly. Now, my output y of t is equal to 0 to t d tau, 0 to t d tau, for which? For t greater than or equal to 0, greater than or equal to 0. And you see, this second integration terms will get added at t equal to 2. Second integration term will get added at t equal to 2. Hence, at the maximum, this first integration can exist till 2. Hence, 0 to 2 y of t is equal to this integration, first integration term. Very simple. D tau integration gives you tau, 0 to t. Hence, my answer is t. Okay. Now, let us second. T can be greater than or equal to 2. T can be greater than or equal to 2, and it can end at 3. Less than or equal to 3. What happens in the second? Y of t, the first integration is already present. Along with that, the second integration also adds, is equal to 0 to t d tau minus 0 to t minus 2 d tau. Now here what happens? It is equal to 0 to t d tau means tau 0 to t minus tau 0 to t minus 2. T minus 2. Hence, my answer becomes like this: t minus t minus 2, because tau integration, tau upper limit is t minus 2 minus 0. Hence, my answer becomes equal to 2. Hence, between 2 to 3, I am getting constant y of t is equal to 2. Now, t greater than or equal to 3, greater than or equal to 3, because my third integration part starts at 3, and where it should end? It ends at 5. Now what happens till 5? 3 to 5, the first integration part, second integration part, as well as the third integration part adds. Hence, y of t is equal to 0 to t d tau minus 0 to t minus 2 d tau minus 0 to t minus 3 d tau. Now here again, tau integration, d tau integration gives you tau t minus 0, upper and lower limit, minus t minus 2, second one, minus t minus 3, minus t minus 3 gives you t minus t plus 2, minus t plus 3. What happens now? T minus 2 cancels out. Okay. 5u minus t. 5u minus t is my answer. 5u minus t is my answer. Y of t is 5u minus t. Between where to where? 3 to 5. Now, t greater than or equal to 5. T greater than or equal to 5, what happens? All these 4, because at 5 the fourth integration will add. Y of t becomes equal to 0 to t d tau minus 0 to t minus 2 d tau minus 0 to t minus 3 d tau plus tau is equal to 2 to t minus 3 d tau. Now let me put these integrations into actions. D tau integration 0 to t gives you t minus t minus 2 minus t minus 3 plus d tau, it is t minus 3 minus lower limit 2, okay, t minus 5. Hence if I analyze this, it becomes t minus t plus 2 minus t plus 3 plus t minus 5. If you see this, t minus t cancels out, minus t plus t cancels out, minus 5 and this 5 cancels out. Totally I get 0. Hence this is what is my answer. I will write the answer in a ordered manner, as well as I will draw the output graph also when I convolute these two signals. I hope you understood what I did. I am supposed to convolute two signals which are pulses which exist from 0 to 3 and 0 to 2. I defined first step, I defined both signals, and then I put them into convolution, and then I applied the basic definition of convolution and put them into integration like this and multiplication, and then very importantly I rearranged them here, which integration term comes first and which comes next. Very simple. If you look into this, you will understand. The lower integration is 0, upper integration t minus 3. Hence here lower integration is 0 and upper integration is t minus 3. Hence this comes before this. And here lower integration is 2 and upper integration is t minus 3. Hence this comes last, because it starts itself at t equal to 5. Hence I rearranged them into 4 terms and then I analyze them to give you the answer. Okay, let me put the complete answer here, into a proper way and draw the output graph. Okay, now let us write our answer at the end. Now see, for t greater than or equal to 0, less than or equal to 2, y of t is equal to t. Okay, let me write it here. T greater than or equal to 0, less than or equal to 2. It is equal to 2, correct? It is equal to 2 for t greater than or equal to 2, less than or equal to 3. Now it is equal to 5u minus t for t greater than or equal to 3, less than or equal to 5. It is equal to 0 for t greater than 5. Now if I draw this graph, it looks like this. Zero, 1, 2, 3, 4, 5. 0 to 2. It is a ramp, t. It is simply a ramp or t. From 2 to 3, it is constant 2. Now 2 to 3 it is constant. 3 to 5 it is a ramp. negative going ramp, minus t is there. It is 5 minus t. It passes through 5, hence it is 5 minus t. And it is negative going ramp. Here it is positive going ramp, negative going ramp. And 5 onwards, it's 0. This is how the signal looks like. Okay, signal looks like. This is output y of t. This is input x of t, and h of t is the impulse response. Output y of t is drawn like this. What is this? This is 2. This is how the output graph. This is how the output graph exists. I have solved it. I have written it in the ordered manner, and I have also drawn the graph. I hope you understood this way of solving if two pulses are given. Okay. If any doubts are there, you please reach me on your WhatsApp group. I can clarify you. Okay then. Thank you.